Hello, in this video we're going to build on what we did last time, and we're going to be describing dilations, reflections and translations, but I'm going to give you examples now of what that looks like. So I'm going to start with one that doesn't require any extra algebra, so you can describe the dilations, reflections and translations without needing to do any manipulation whatsoever. So let's look at something like y equals 3x plus 3 cubed minus 2. Alright, and I want to describe the dilation, reflection and translations that happen to a cubic, the basic cubic, y equals x cubed, to get to this graph. So starting from y equals x cubed, how do you get to this graph? Because it is a cubic. Well, we go in this order. We go dilation, reflection, translation. So let's look at the dilations. Well, if we look at the coefficient of x, that's got to be 1 there. So we can leave that alone. However, we have a 3 out the front. And this 3 is kind of like that a times f of x we encountered last time. So we know the first thing we're going to state is, I might put it over here, dilation by a factor of 3, because this is kind of like a times f of x, dilation by a factor of 3 from the x-axis. It's got a dilation by a factor of 3 from the x-axis. Sweet, we've done the dilation. Are there any reflections? Well, there's no negative sign here in front of the x, and there's no negative sign out the front here. So we can say no reflections. So let's leave reflections. Let's look at translations. We've definitely got some. So here we can see we've got x plus 3. So that's going to be moving 3 units to the left and 2 units down. So we can say that we have translation of 3 units left and 2 units down. So this sort of question can pop up on exams. They can ask you to list the transformations required to get from one graph to another graph, and you'd have to go through and list what's required to do that. Let's look at a trickier example, one that might require a bit of algebra, and it's going to include what I like to call step 0. So if dilation is step 1, reflection is step 2, translation is step 3, there's what I call step 0. So let's stick with the cubics, and we're going to look at a really ugly cubic. Alright, let's see here, 5 plus 1/2 x cubed. Alright, the reason this doesn't look nice is because we have a coefficient of x here of 1/2, and this 3's out the front here. This is a classic exam trick. They will always try to trip you up by putting this number over this side. They'll always try to do that. So I'm going to rewrite this with the 3 on the other side. So this is positive 3. So I'm going to rewrite this by putting that 3 over here on the other side. So I've got plus 3. This just makes it look a bit nicer, And this is bound to come up, this sort of trick on an exam. Remember, they're trying to put as many little things in there to separate the state. So any little trick they can put in, they're likely to do. All right. So everything I'm doing here, I like to call step 0. Most importantly, you have to make sure that the coefficient of x is 1. Before you can do all this, dilation, reflection, translation, you have to make sure that coefficient is 1, which means you have to factorize here. So I'm going to take out the factor of 1/2. So let's say I'm going to use big brackets there. I'm going to take out the half. Well, if I take out a half from 5, that's going to leave 10, because half of 10 is 5. And then we've got plus x, like that, and that's still all cubed. This is happening inside those brackets, and then plus 3. Alright, let's keep going. I'm doing this step by step to show you everything I do. Now I'm going to rewrite it so we have x plus 10 instead, because we know that 1 plus 2 is 2 plus 1. So I'm using the commutative law of addition to rewrite 10 plus x as x plus 10. Then I'm going to cube that half. So a half cubed, well, that's 2 times 2 times 2 down here, so that's an 1/8. So I can cube that, that's an 1/8. And I can cube this part, which gives x plus 10 all cubed. And then I'm going to add the 3. Finally, I'm going to expand out these brackets. So -4 times an 1/8 gives us -1/2. And we get x plus 10 cubed plus 3. This looks much friendlier. We can describe what's happening here. This looks hideous. Would be really struggling to describe all the transformations here. This looks much nicer. So let's describe the transformations. Well, there's no coefficient of x, but we do have a coefficient out the front. So that's a dilation by a factor of, well, it's a half, so 1/2 from the x-axis. See, this is where it comes in handy, knowing these phrases. If you just know them, then you can look at a function and you can just put it on your page. Reflection. There's a negative sign there. We know if it's out the front that it's a reflection in the x-axis. So we have a reflection in the x-axis. Alright, we've done the dilation, we've done reflection. Next is translation. Well, we have a translation by 10 units to the left and 3 units up. Translation by 10 units to the left and 3 units up. There we are. So the tricky part there is doing the algebra to get it into a nicer form here so we can describe the dilation, reflection, and translation. So that's 2 examples of a cubic. That's a pretty scary example. So right now, if you're feeling comfortable with that and you can do a question like that from the book, I would say you would be pretty confident with dilations, reflections, and translations. However, let's do another example. Let's do a different graph. Let's call this one example 3, and I think we're going to do a truncus. Let's look at y equals 5 minus 1 on x plus 4 squared. Alright, once again, classic. They're putting this number on the left side when we can put it over here? Let's rewrite it straight away. Step 0. Rewrite it. There we are. It's immediately much easier to read. They'll always do that trick. I've seen it happen pretty much in every practice exam I've seen, or VCAR exam. They try to do something like this where they check, hang on, does this person know what addition and subtraction actually are? So they'll always tie in a trick like that. Looks like this, we can do our DRT. So we're starting with a basic truncus. Let's look at dilation. Well, that's a 1. That's a coefficient of 1, so no dilation. Let's look at reflection. Yeah, definitely. There's a negative out the front. That means we're flipping in the x-axis. So we can say reflection in the x-axis. And I hope you're finding that previous video useful as a kind of cheat sheet to figure out which one to use. And we have translation of 4 units to the left and 5 units up. Translation of 4 units left and 5 units up. Alright, that was too short. Let's do one more. Let's do something with a square root. So I'm going to pick an example. Example 4. Give this one a go. So you can pause the video and you can give this one a go and then see if you get it right. So let's see. Y equals -2 square root of 4 plus x. Alright, if you want to have a go, pause the video, like actually pause it, have a go at this question, describing the transformations, and then play it again. Okay, let's see. Well, I'm going to rewrite it because I like to. X plus 4. Let's see, dilation by a factor of 2 from the x-axis because it's right out the front. Dilation by a factor of 2 from the x-axis. What's next? Reflection. Yep, reflection in the x-axis. And translation by 4 units to, units to the left. There you are. I hope you got that right. This whole process, I know the writing takes time, but using your own shorthand when you need to, or looking at it, or doing it mentally, or however you want to do it, should take you about 30 seconds when you've gotten quick enough. In other words, you should be writing slower than you can think. You should have already thought about it all while you're writing. That's the speed you want to get to if you want to be really confident in the exam. But I hope this has helped, because I feel like the book doesn't target this topic very thoroughly. So it covers each graph, when really all you need is that cheat sheet, and once you can apply it to a few different types of graphs, you can apply it to all of the 8 standard graphs. So keep in mind, yeah, this is a bit tough. However, it's essentially condensing a lot of work that the book moves through a bit slowly. So that's why it might be a bit intense. Alright, if you have been, thanks for watching.